Hi friends and my dear students, in 12th Physics second volume 7.4 Continuous X-ray Spectra. Continuous X-ray Spectra. In last class we have seen how to produce discharge tube X-rays are produced. When the fast moving electron hit the surface of the target, then X-rays are produced. Today we are going to see the two important points. One is the spectra are continuous. The second thing, why for particular mode of particular wavelength the peak nodes are available and at a particular wavelength. That's an important concept we are dealing today. This is nothing but line spectra. Even though we are getting continuous spectra, this line spectra is obtained only because of it represents the characteristics of the target. That's the thing that we are going to see today. And how can we obtain this line spectra from the various level? First, before that, we have to first proof of continuous X-ray spectra. When the fast moving electron penetrate an atom, what happened here? It approaches towards the nucleus, so that there may be a repulsive force. The repulsive force to these electron rays, that's why the electron acceleration may increase or may decrease. Two things may be happen. One is accelerating the electron. Fast moving electron consists of electron, and the acceleration of electron are increased or it may be reduced even in the value of negative, like that. That is called decreasing value of acceleration. This is called increasing value of acceleration of this electron. Why it was happened? Only because these electrons are interacted with the positive nucleus, then there may be interaction between these electrons as well as the nucleus. That's why the acceleration may increase or decrease. And because of the reason, the path of the electron may affected. It will not travel in a straight line manner. It may be deviated, and path of the electron may be affected. The first point, acceleration may increase or decrease. The second point, the path of the electron which are affected. Two things are very important. Now, the decreasing electron or deaccelerated electron produces some radiation. Decreasing electron, the radiation produced by this decreasing or less negative accelerating electrons are called Prums, Prums trilon, P-R-E-M, Prums trilon, S-T-R-H-L-U-N-G. A new name. It is very difficult to understand, but very easy. from still long, or it may called as breaking breaking radiation, breaking radiation, breaking radiation. This was happened. So the main concept, whenever the fast moving electron enter to the target of any atom, then it move towards the nucleus, then there may be interaction between the nucleus and the electron, then the acceleration of electron may increase or decrease even in the negative level, and because of that reason the path of the electron may be deviated. Now 2 point is clear. Third point, when the decreasing accelerated electron produces radiation, and such radiation is called breaking radiation or Bremsstrahlung. Bremsstrahlung. This is a valuable point that we have to understood. Then next we have to skip over to the next point. The energy of photon emitted. Here the energy of the photon emitted during this process of the fast moving electron interacted with the nucleus, then there may be a partial energy may be radiated or total energy may be radiated. Two things are happened. The total energy of the initial electron, that is called E1. Now the outcoming photon energy become equivalent to E1 or less than E1. That means if the electron radiate the energy as a photon with partial energy, then we get a less amount of energy of photon. If the electron energy are completely transferred to the photon energy, then we are getting maximum energy of X-ray photon. Already we studied. Here the photon energy become higher. Now from this we conclude that it possesses, the outcoming photon possesses minimum to the maximum. That is why we are getting continuous spectra. Lowest wavelength to the highest wavelength. That is a very important point that we have to understand here. Why continuous spectra are emitted during the process of the electron hitting the target. That's the reason. Suppose, let us assume the initial energy of electron is called E1. Initial energy of an electron. And the final energy of the electron E2. Now E1 is higher and partial energy are transferred to the photon energy. Therefore E1 minus E2, that is equal to h nu. This is called photon energy. This is called radiation of photon energy. Okay. Radiation of photon energy are equivalent to E1 minus E2 equal to h nu. Okay. Now I have to consider the initial energy of E1. Energy equal to E1. It is the kinetic energy of this electron is dependent on E into V. Here E is the charge of the electron and V is the voltage applied between the anode as well as the cathode. So now I want to give one famous explanation, a very important explanation. Here, when we are not changing the accelerating voltage, you are not changing the alternating voltage, that is kept as a constant. You are changing the target. You are changing the target, tungsten, molybdenum, RCCM, or whatever it may be the metals. Then the wavelength of minimum cutoff voltage, which will not be altered. It is common for all metals unless if you are changing the voltage applied between the terminals. That's a very important concept. Okay, now as per the kinetic energy of the electron is equivalent to EV, then we already know E1 minus E2 is equal to h nu. And if suppose, in case, what I assume that the total energy of the electron are completely transferred to the photon energy. What happened here? The frequency is called maximum. The energy is called maximum. That is the very important concept. If the total energy are completely transferred to the photon, then the radiation of the photon energy frequency is high as well as energy is high. So that we can write this one is equal to h nu naught. But the kinetic energy of the initial electron is called EV. That's called h nu naught. Or we know that C equal to nu lambda. Or nu equal C by lambda. Or nu naught, when you put nu naught, then you have to put lambda naught. Then nu naught become C by lambda naught. Substitute the value in the equation, we get EV equal H instead of nu naught C by lambda naught. Are you clear? Now we have to calculate the wavelength of cutoff voltage of this photon. Then lambda naught equal to Hc by E into capital V. V is the voltage, accelerating voltage between the anode and cathode. H is Planck constant and C is the velocity of light. E is the charge of the electron. By substituting all the known values, 3 into 10 power 8 per 1.602 into 10 power minus 19 into voltage. Except these are all solvable. By solving this, we are getting the wavelength of lambda 12,400 Armstrong. It is nothing but 10 power Armstrong is equal to 10 power minus 10 meter. We are solving this equation, we get 12,400 into 10 power minus 10 meter, or we have to put Armstrong divided by volt. This is the equation for the wavelength. Here the wavelength is dependent on the potential, but not dependent on the target of the metal, target of any metal. Whatever it may be the metals, you can change it. Then the wavelength which will not be altered unless you are not changing the accelerating voltage. That is a very important concept. If you are changing the accelerating voltage, then the cutoff voltage may be varied. But keeping this accelerating voltage is constant, then the target may be changed, even though whatever may be the target, the lambda naught is constant. That is a very, very important concept that you have to understand. This relation is given by Duyan Hunt, Duyan Hunt, Duyan, Duyan Hunt, Duyan Hunt, Duyan Hunt equations. This equation is called Duyan Hunt equations. From this equation, we assure that the lambda naught or minimum wavelength, which will not depend on the target, which will depend on the accelerating potential. If you are keeping this accelerating potential is a constant, if you are changing the target, then there is no alteration in the wavelength. That is a very important point that you have to remember. Cutoff wavelength is constant. Cutoff wavelength is constant. So that from this above two explanation, first we already proved that it is a continuous spectra. The second one, the explanation of cutoff value are explained very well, so that both theory are explained by means of photon radiation. That's why already in last class there may be two negative points of Coolidge discharge tube not satisfied to explain the continuous spectra as well as the minimum wavelength. This is a necessary condition to eradicate or to explain clearly about the minimum wavelength as well as the continuous spectra. Are we clear? Very good. Now we shifted over the next. In case if the higher velocity electron, whenever moving towards the target, the nucleus here positive first orbit K, there may be some electrons here or two electrons here, and L orbit likewise there may be some electron in another orbit like so. In case this electron which will knock out when move towards this interaction, move towards this atom, the interaction which will happen between the nucleus as well as the electron ray. If suppose these electron rays are capable to knock out this electron to outer, what will be happen? There may be a vacuum. There is no electron in the K shell. Is it possible without electron the stability of an atom can be explained? No, not possible. If there is no electron in the K shell, how shall be the atom is stable? Quite not possible. That's why the electron from the outer cell or jump over to the K cell so that the bombarded electron or ejected electron are rearranged by means of another orbital to the K orbit. Suppose this is called L, M, N and O. The electron can be able to jump from L orbit, M orbit, N orbit, O orbit to the K orbit and to fulfill the vacuum. That's why we are getting line spectra. In last class we already draw a graph, wavelength with intensity. This is called tungsten and this is called molybdenum, like this, the curvature like this. Here at a specific particular wavelength, there may be nodes, upper nodes which will be available, and only because of this reason these electrons are evacuated or bombarded from K k orbit, k cells to the outer. To fulfill these places, the electron can jump from higher energy level to the lower energy level of k. That's why we are getting line spectra. For example, we can consider this is called k orbit. This is called L, M, N, O. If suppose any electron which are fulfill the k electron orbit jumped from L orbit, then this may called as k alpha. If it is jumped from M to k orbit, k beta. Now, the energy difference between these two. What is the energy difference? Suppose if electron available in L orbit, the electron available in the k orbit, there may be energy difference. That energy difference are emitted by means of this peak. That's why it may be reached to the peak. That's why we are getting spectral lines. That's why we are spectral lines to the specific wavelength, and it represents the characteristics of the target. Likewise, it may be possible to get all jumping from higher level to the lower level, k alpha, k beta, k delta, k gamma. Likewise, if suppose if L electron in the L orbit, there may be outgoing electrons are possible. Then there is a vacuum in the L orbit. By means of electron hitting this nucleus, the electrons available in the L orbit are bombarded to outside or knock out the electrons in L orbit to the outer side. There will be vacuum. That's why in the higher energy level of M and N, O, there may be a jump from M, N, O, P. This is called K, not K, L alpha, L beta, and L gamma. L gamma. Likewise, in other words, if suppose the knockout electrons are happening in the M cell, then it may be fulfilled from the jumping of electrons from N orbit or O orbit to the M orbit, M alpha, M beta. That's why we are getting spectral lines. These spectral lines indicates that it is nothing but for a particular wavelength, it represents the characteristics of the target. That's why it may be called as characteristics X-ray spectrum. Characteristics X-ray spectrum. This is called characteristics X-ray spectrum. This is very, very important to analyze the concept, to understand the concept. I think you are clear. Now, this is called tungsten. Already last class I explained. This is called molybdenum. At the voltage level of some potential voltage or oscillating voltage. Here the nodes indicate that there is no change in the V. We are not changing V. Even though we are getting the nodes upper to peak value. This was happened only in the K orbit. That's K alpha and K beta. And two spectral lines are able to explain. That's why this is called even though we are getting continuous spectra, here we are getting line spectra. This is a very clear understanding about the line spectra, how it is possible to obtain. That's a very important. This is very, very important 5 mark questions. Then next, what is the uses of X-rays? Very simple question. It may also ask in 3 marks or 2 marks or in 5 marks. Sometimes it may be asked in 1 mark also. And specifically if you are asking in industrial purposes or in medical purposes or identification of disease. Likewise, if they ask any question, then you can give the exact answer within a line itself, that's enough. Suppose application of X-rays, the first one is medical purposes, medical diagnosis. How can we predict what are the diseases which are affected by means of human body? When you are affected by means of any disease, then doctor asked you to take X-ray. Then after washing the X-ray, you got it and handed over to the doctor. Watching the X-ray, he immediately told you are affected by means of cancer, or you are affected by means of leukemia, or you are affected by means of any tumor, or affected by ulcer, or gastritis. These are all diagnosis purposes. Medical diagnosis, medical purpose. When utilizing this X-ray in medical science, diagnosis the disease. The next one. How can we utilize this X-ray to cure the medical therapy? Second one, medical therapy. What is my medical therapy? Suppose some tissue in your leg or stomach or wherever it may be are affected, or cumulative of some unwanted bacteria or enter your body, then by means of X-ray we identify. Then how can we cure it? Medical therapy, when you are applying this X-ray on that particular spot for particular seconds, and the intensity may be varied, depends upon how much you are affected, then it may be eradicated day by day. At last, you may cure completely with the help of the medical therapy. That's the uses of medical therapy. That's the use of X-ray to cure our disease. Third one. In industrial purposes, we are mainly utilized to identify. Suppose let us consider a metal. The molecules or atom or molecules are arranged in some sequence manner. If you identify what are the methods that are arranged, then you have to, with the help of X-ray, you can identify the arrangements of the order of atoms or molecules of atom inside the metals. That's a very, very important. This is the first point. The second point, if you want to make a perfect rod of metal without any crack or without any gap or air, anything else, then if you are sending X-ray, then we can find out this mistake, then we eradicate this one. That's a very important thing. Suppose that you imagine a bus or conductor, you have to assume this is a bus wheel. There may be a rod joining these two things, and we are more than 100 people are travel, This was very not enough size radius, small radius. If it was affected by means of any crack, then our life is very mysterious. The bus will going to be, it will broke down, then what will happen? Accident may happen. That's why to find out whether it is broken or cracked or anything else, the bubbles, air bubbles are available inside the rod that we can identify. For these purposes, even nowadays, we are applying all these all many kinds of materials are undergone by the X-ray test. Third one, we can identify unwanted materials. Unwanted materials, if you are having in your bag, then by means of X-ray sending, we can identify that particular unwanted materials. So it may be mainly used to verify whether you are bringing the unwanted materials in anywhere else. That's a very, very important purposes. So these are all some uses, but not all uses. Some uses you have to study about in your textbook. This is a very, very important chapter to fulfill. I hope you may understand clearly. You have understand clearly. Now, if you want to answer 1 mark question or 2 mark question or 3 mark question or 5 mark question or NEET exam, whatever it may be, you must give importance to each and every concept which are available in your textbook. Without understanding the concept, without understanding the actual meaning of the textbook, then you cannot be able to solve 1 mark question or 3 mark sums and compulsory sums and not eligible to enter the NEET exam. If you boldly and bravely enter to the NEET hall only by understanding the concept thoroughly, then whatever it may be the question may be asked in the NEET or anywhere else, you can easily solve. I can give furthermore more videos regarding NEET as well as how to solve the problem, how to write the equation, how to answer. Suppose 5 mark questions. 5 mark question in first to fifth they are putting tick, then margin itself you are getting 5.